Assalamualaikum warahmatullahi wabarakatuh, and good morning. Okay, today I want to share with you, regarding the next topic for mechanical testing for metal. Okay, today I want to talk about the hardness. Okay, what is the hardness test? Okay, hardness test is to measure the resistance of a material to penetration by a sharp object. Okay, I think you seen before in your daily life. Okay, how the hardness play important role in order to determine the properties of the materials. Okay, for hardness test, normally we divide it into three type of hardness test. Number one is macro hardness. Okay, and number two is micro hardness, and number three is nano hardness. Okay, what is the macro? What is the micro? What is the nano? You can see the definition here. Okay, but normally for metal testing, okay, normally we focuses on only two type of hardness test, which is macro and micro test. Okay, um, this one only the explanation about the hardness test. Okay, uh I don't want to talk more on this because this only a statement that I want to share with you about this. Okay, I think this slide is very important for you to understand what is the hardness is. Okay, I think you now you are in the third year. Okay, you are supposed to know how to measure the hardness of the metal. Okay, normally hardness is a plastic deformation properties of the metal. Okay, what's the meaning of permanently uh atau no, not permanently, plastic deformation. As you know, when we talk about plastic deformation in stress strain curve, meaning that the metal properties already exceed the yield strength of the metal. So meaning that when you change, let's say when you pull or when you apply a small load on the metal, okay, the metal cannot go back to its original shape. So normally for hardness test, we can call as a plastic deformation testing, which are when you apply a load on the metal. Okay, if the metal cannot absorb or cannot resist the load applied onto the surface, the metal will be dent. Okay, dent tu bermaksud kemek lah on the surface. Okay, so uh, here is a schematic diagram shows that how the hardness test has been done. Okay, normally hardness test, maybe later I will share with you. For hardness test we have a different type of hardness test. I do believe you know already what type of hardness test has been available out there. Okay, but here I want to share with you how the mechanism uh, of the hardness test. Okay, as you can see here, let's say you have one piece of block metal, and then maybe you can choose one type of hardness test, for example Brinell or Noob, Vickers or Rockwell. Okay, and then you apply a certain load. Okay, the load is varies depending on the standard, okay, the standard testing method, or we call it STM, GIS or ECE. Okay, when you apply the load and then when you remove the load, okay, you can see the dent surface area on top of the metal surfaces. Okay, so meaning that when you do the hardness test, the key indicator is the diameter of the dent area, as well the height of the dent uh, dent formation. Okay, meaning the area and height of the dent formation. Okay, let's say when you apply, let's say in this case, okay, you can see when you apply the load with the uh, ball shaped indenter, you can see they have a dent on the surface. Okay, meaning that if the diameter of the dent surface and the height of the dent surface is higher, meaning that the material have low hardness. Meanwhile, when you apply a same load, okay, as previous, and then you found that the diameter of the dent and the height of the dent is very small, so meaning that that material shows high hardness properties. Okay, here is the example, okay, of different type of metal, okay, and its hardness properties. Okay, of course, from plastic shows the low hardness, and then when you go to uh, brass alloys, nitride steel, and diamond. Okay, diamond, the hardness is I think the highest among the materials. Okay, that's why diamond cutter has been used in order to cut, very high hardness material, metals, carbon, uh, especially metal. Okay, when you deal with the metal material, okay, the diamond has been commercialized use in the market now. Okay, here is the example of the hardness test instrument. Okay, the hardness test in our school we have those hardness test, Brinell, Vickers, Rockwell, as well the Knoop. Okay, you can see later when you go to the lab for EBB 317 for the next semester. Okay, you will go through all this testing. Okay, here is the hardness testing techniques. Okay, hardness testing techniques. Okay, as I mentioned before, for hardness test we have Brinell, Vickers, Noom, and Rockwell. Okay, do remember each testing technique have their own character. What is the character means? Okay, let's say you use Brinell, especially the indentation, the indentation shapes, okay, as well the dimension of the indenter. Okay, the load might be same, but the indenter shape and size might be different for each testing method. Okay, for example, if when we talk about the Brinell, okay, the indenter must be sphere, steel, or tungsten carbide with a certain diameter, okay, uh, and others, okay. And then let's say the Vickers must be something like V shape indenter with a certain length and certain dimension. Meanwhile, for Noob, micro indentation testing, okay, you need to have something like the pyramid shape of this. Okay, you can see the between Vickers and Noob, we have almost similar. For side view, we almost similar shape, but however, when we see on the top, the shape is different. Okay, the Vickers, the diamond shape looks like in cubic shape. However, when we using Noob, you can see something like diamond shape samples. Okay, for Rockwell, normally you can use either V shape or ball shape of the indenter. Okay, this one you should understand how to differentiate this. Okay, and this one has been has been used many times in final exam, even in the test, even in the quiz. So maybe in your notes you should put the star for these pages. Okay, all right. This one just a conversion. Okay, this one, uh let's say why did this conversion is important. Okay, let's say when you work in factory, okay, your boss maybe ask you, okay, Khairul, you need to measure the hardness by using noob, but actually in your lab, in your laboratory, or your QC department, you only have Vickers instruments. Okay, therefore, this conversion table is really important. Okay, although your boss asks you to measure the knob measurement, but you have only the Vickers instrument, so you can use the Vickers instrument, and then later when you get the data, you need to convert into the knob table. Okay, Here is the correlation between the hardness and tensile strength. Okay, as I mentioned, for tensile strength, let's say for example here, okay, here give you the hardness test, okay, Rockwell and Brinell. Okay, just look on this. Okay, y-axis and x-axis. Okay, y-axis tensile, x-axis is Brinell hardness test. Okay, you have three example of metal material, brass, cast iron, and as well as steel. Okay, for example, if the between these three, brass, cast iron, and steel, shows that the steel shows the high tensile strength in comparison with brass and cast iron. Meaning that uh, for steel, okay, as you can see here, for steel, when you increase its tensile strength up to 1500 here, and then you can see the Britnell hardness number is increased. Okay, in this case, you should think, okay, you should identify the answer. What happened if the hardness number is high? Either the hardness is become stronger or the hardness become lower. Okay, this one you should identify by your own. Okay, so not me explain to you all, but you need to identify why. Let's say the tensile strength is high. What happened to the Brinell hardness number? Okay, so I think that's all from my side. Uh, if you have any question, please post in the group so I can answer your question, or maybe later we have a video conversation in order to answer all of your questions. Okay, I think that's all from me. Thank you very much.